peculiar, mysterious, magical. Chameleons are familiar to almost every person on Earth, yet they are found in just a handful of places on the planet. We still know so little about them. Join us as we embark on a quest to reveal the secret life of these strange, exotic creatures. And with the help of the latest technology, we'll go right inside their amazing world. We'll reveal new science and solve some age-old mysteries. From the island of Madagascar, the forests of East and Southern Africa, to the sand dunes of the Namibian desert. Meet the chameleons of the world. The distribution of chameleons is confined to Africa, the Mediterranean, the Arabian Peninsula, India and Sri Lanka, and also the island of Madagascar. Travel with our two experts as they reveal the amazing world of chameleons. Marius Berger explores the world in search of frogs and reptiles, and he has a specific interest in chameleons.
These are the moments that I live for.
Anthony Herrell has long been interested in functional morphology and investigates the feeding and movement of chameleons in his lab in Paris. Witness never-been-seen-before X-ray imaging and high-speed photography. In this episode, we investigate the mechanics and the design of the ultimate predator. We dissect it to the last bone, to the last nerve, and recreate any bug's worst nightmare, a near-invisible phantom of the forest. Chameleon design is ingenious. It's neither an armor suit nor a robotic simulation. In fact, it's nothing predator-like. But an in-depth study of this perfect hunter reveals the extraordinary evolution of a reptile body which resulted in a creature that is built for the kill. With a stealthy movement, a weapon perfectly positioned for frontal attack, a support structure to focus on the target, pinpoint vision, these assassins move into position. Then a silence before an accurate, perfect attack. Perhaps the most famous attribute is the chameleon's ability to catch prey over a distance using a projectile tongue. But for this weapon to be used most effectively, the sniper must also be an expert at hide and seek.
Chameleons are renowned as masters of disguise. And this little fellow, certainly the best of the best. Still can't see it? Well, that's the whole idea. Camouflage has two functions. Number one, you want to remain undetected to your predators. A rainforest like this is full of snakes that would love to snack on a juicy chameleon. And of course, you also don't want your prey to see you. Sitting there, motionless, invisible, and the little insects land just within striking distance. The Uzumbara pygmy chameleon is trying his hardest to look like lichen of a dead branch, and he's doing an excellent job. He's got the right coloration, the right skin pattern. He's even got tiny little spines that break the outline of the body. And he's using stealth, not moving, or if he's moving, so slowly that it's not really visible. Impressive.
The chameleon's tongue strikes again. Back in the lab in Paris, science provides us with a blueprint of chameleon design. The latest technology, high-speed photography, X-ray filming and microcomputer thermography scans take us right inside the body of a chameleon. At the forefront of this research stands evolutionary biologist Dr. Anthony Herrell, based at the Natural History Museum in Paris. His discoveries have corrected many of our previous misconceptions.
Technology has really changed the way we look at science. Especially in my line of work, technology is extremely important to understand how animals really work. So what we're trying to do is explain animals in their natural environment. And to do that, we need to look at the animals in more detail, and we need to understand how animals work. Take, for example, a chameleon. What's the coolest thing about a chameleon that you can really think about? Is it the hands that are special, the color changes, the eyes? No, it's the projectile tongue. It's the tongue that flies out of the mouth of the chameleon, captures the fly sitting on another branch, and brings it back to the mouth. Now, if we want to understand how that tongue really works, we need to look at slow speed, and we need to look inside the animal. And I don't mean cutting it open. What we're going to do is look inside the animal using high-speed X-ray technology. Let's have a look. All right. Breakfast served. Look at it. Oh, look at the tongue. Look at the tongue. It's coming slowly. There it goes. There it goes. All right, he's got it. Cool.
Using high-speed X-ray cameras, Anthony investigated the trigger mechanism of this phenomenon.
Wow, did you see that? That was pretty cool, no? I bet you didn't really see that. Now, how it does it is really interesting. And the trigger to that mechanism is something we can only understand by looking inside the animal using X-rays. Now, what's really important about it is that the tongue actually acts like a spring. So the chameleon actually compresses a spring inside its mouth and then uses its tongue bone, the bone inside the tongue, to release the trigger, and then the tongue shoots like a spring out of the mouth towards the prey. And that's how this little guy actually shoots out its tongue. Think about it. How does a chameleon tongue work? How does the animal manage to shoot out its tongue in a fraction of a second to reach that prey, which is 2 body lengths away from it? I mean, that's really amazing. So how do we understand that movement? How can we explain it? Well, the only way we can do that is by using this technology. And the first time I saw these images of the tongue moving towards a prey item, it was really amazing. Because for the first time, I could really understand how that mechanism may potentially work. And so if you look at that image of the chameleon shooting out its tongue, the first thing that you'll notice is that the hyoid bone, so the bone in the back of the tongue, is unfolding first slowly, but all of a sudden snaps and triggers that whole ballistic tongue movement. And the tongue just flies out under its own momentum towards the prey.
Everything in the building blocks of the chameleon contributes to the success of chameleons as predators. Its skin is able to change colour. Very handy when you want to disappear into the background, and also when you need to send a signal. Kirindi, Madagascar. The forest is peaceful, and so is this female of the Labord's chameleon. But not for long. The short breeding period, the male Labord's chameleon is always on the lookout for amenable females. But Our Lady is already carrying eggs, and upon meeting each other, she undergoes a dramatic colour change. Her skin is literally speaking, not interested. But not all males will take no for an answer, and she resorts with an ultimate rejection, swaying to and fro, mouth agape, and our Casanova scurries away.
This is not a scene that you will see every day. A male Labord's chameleon accidentally stumbling upon a female of his own kind. And what a lot of drama.
The colour change happens in the most ingenious manner. The chameleon's skin consists of 4 different layers, containing specific primary colour pigments. Colour change happens by widening and reducing windows in the skin to reveal more or less of a specific colour. Additionally, colours may be overlaid to produce completely different colour hues. But the darkening of chameleons, usually to indicate a stressful mood, happens entirely differently. Dark melanin spreads along the upper surface of the skin by means of a fine network of tentacle-like tubes. Darkening the skin like a black cloud darkens the land. So the chameleon can change colour and capture its prey over a distance with its incredible tongue. But there's more. Independently swivelling eyes mounted on conical turrets, allowing for 360-degree vision. The chameleon's brain has to analyse 2 different images at once, an accomplishment which human brains would struggle to comprehend. From a chameleon's perspective, it is certainly an ecological advantage, being able to target your prey whilst at the same time looking out for your enemy. The proverbial eyes in the back of your head. The final building block that makes a chameleon unique is its feet. These are unlike that of any other lizard. A highly specialised fusion of digits form claspers. This is a useful adaptation for tree-living existence. What's more, the hands have the fingers fused, 2 on the outside and 3 on the inside, whereas the feet have 3 toes fused on the outside and 2 on the inside. Each digit is adorned with a small, sharp claw to improve the grip.
X-ray cinematography has revealed something very interesting about how chameleons move. Because if you think about a lizard or many other sprawling animals like crocodiles, alligators, lizards, all those things, when they move, they actually put their legs to the side of their body. And when a chameleon moves, it has to move on really narrow substrates. It's living out in the trees on small branches and everything. So it has to put its hands under its body to keep its stability. Now, if you want to do that, if I put my hands like this and I still want to move, I need to do something very special. Otherwise, I can only take very short steps. So if I want to take a decent step, I have to move my shoulder forward. And if you look at a chameleon, the interesting thing you see using X-rays, because otherwise you won't see it, is that the shoulder blade actually slides along the body forward, allowing a chameleon to actually take a much bigger step than it could do otherwise. And again, it's one of those things that we never could have dreamt of what is going on there without the use of that X-ray vision. And it's really looking inside the animal that's telling us how these animals work and how they really are adapted to their natural environments. So it's a really interesting tool to use in this context.
This is all well and good for the tree dwellers, but maybe not the best design for ground-living chameleons. In the lab, Anthony discovered that the leaf chameleon of Madagascar has found an alternative strategy to deal with this apparent handicap. Something that was never obvious until scientists had a closer look in laboratories while studying locomotion.
So high-speed imaging has revealed so much to us. I mean, high speed, especially in combination with your X-rays, about chameleons and how they move and what they do and how they're adapted to their natural habitat. But there's one thing which is actually really cool, and it didn't require any high speed, and it didn't require any X-rays. Now, if you think you're walking around here in the tropical forests of Madagascar, you're walking through the bush, you're looking at all the interesting animals, and all of a sudden, if you look down at the ground, not just up in the trees, you'll see a very small chameleon. It's a little chameleon of the genus Brookisia, it's called, and it's a ground chameleon. So its main habitat is out there on the ground. Now, what was interesting about this little guy is not just the fact that it's small and living on the ground, but if you see how it moves and you put it on different branches, you'll see something very interesting. Now, a normal chameleon, as you know, has very specialized hands that allow it to hold on to a substrate. So it allows it to keep its stability, move about very nicely. But what happens if you make the substrate bigger and bigger and bigger? Those little hands, especially those little guys, can no longer hold on to the substrates. They can no longer grab it. And what these little chameleons do is something you can never have guessed. They actually use their tail as a fifth limb. They have their fore, and they're going to use their tail to generate an extra point of pressure to give them more stability, just as if you were walking with a walking stick. Just kind of unequal terrain, you want extra stability, you use that walking stick, extra point of contact, and that's what these little guys do. And as far as we know, no other chameleons do that. So if you look at these little chameleons here, they're ground chameleons of the genus Brookisia. And if you look at both of them, you'll see that they're doing something very, very different. The guy in the front here, moving on the broad substrate, is actually pushing with his tail on the substrate with every step. The guy on the narrow substrate here is actually keeping its tail nice and straight. This is very unusual. And this is kind of what you would expect these chameleons to do. They're on a narrow substrate. They can use their hands, which are really specialized for grasping, to hold on to the substrate. The interesting thing is that these chameleons actually live most of their life on the ground. And when they're on the ground, they can no longer hold on to the substrate. And to compensate for that loss of stability, they're actually going to use their tail. So these chameleons are highly specialized to use their tail as a fifth limb to give them extra stability when they're walking on broad substrates. And this is something we've discovered only recently, right here in the lab.
The tail is not to be underestimated in the acrobatic lifestyle of chameleons. It is truly prehensile, a fully functional fifth limb. Moving through the branches for some might be the road less travelled, and on a daily basis, chameleons have to navigate three-dimensional routes. a lifeline for any Cape Dwarf chameleon making its way through an obstacle course of reeds swaying in the wind. So this is what it takes to be a chameleon. But every young hunter has to crawl before he can become such an arboreal acrobat. A newborn Stenford's chameleon peeps out on an unfamiliar world. This naive explorer may want to ponder its next move, but the need to feed is strong, and so he embarks on his very first hunt. But he's not the only hunter out on the prowl. Fortunately for our young explorer, parents do not view their own offspring as a meal. Instead, our young adventurer gets a head start in life by hitching a ride on Dad's back. Chameleons in Greek means dwarf lion, and sometimes, when seen walking or hunting, it seems just to be named after the king of beasts. These colourful phantoms are varied both in their design and distribution. Ranging from the horned chameleons in East Africa to the dwarfs of Southern Africa. Some live in evergreen forests and others in the scorching deserts of Namibia. Some are larger than you would ever imagine, and others so small you would find it difficult to spot, even when right in front of you. Each, regardless of its size or where it lives, is built for one thing and one thing only: to be the perfect predator. Next time in Chameleons of the World, we journey for the last time with Marius to glimpse upon the everyday life of chameleons.
Yes!
How they reproduce, evade predators. Anthony comes second.
240 newtons, don't even compare.
And debunks the myth of the sticky tongue. Join us for another fascinating look at the world of chameleons in Chameleons of the World.